So we can then start sketching graphs showing inflection points, adding on to what we've done before. So the first thing is we need to find zeros. So we need to factor this. Okay, so I want to factor this. I need to find a factor that works. Okay, so I'm going to use my factor theorem. I'm going to plug in 1. Okay, when x is equal to 1, I don't think it's going to work. I get 1 plus 3 plus 5. Oh, that does work. 1 plus 3 plus 5 minus 9 is equal to 0. So there it is. There's one of my factors. So my f of x can be written in factored form. Okay, one of my factors is x minus 1. Okay, so I just have to break down the rest of that quadratic. I'm going to use synthetic division here. So I'm going to use x minus 1. Okay, I'm going to use a factor. I'm going to subtract. So I'm going to multiply and subtract. Multiply and subtract. Multiply and subtract. We need to end up with a remainder of 0. So I know that my quadratic is x squared plus 4x minus 5. So I'll factor that into x plus 5, x minus 1. Ooh, so we've got a double root at negative 1. So we can write our zeros at 1, 1, negative 5. So we have a 0 at negative 5. So it's going to go through that one, and it's going to bounce at this one. Okay, so those are our zeros. Our y-intercept is going to be 5, so I'm just going to make sure that I have a pretty good idea what this looks like now. It's going to probably go through like that, bounce like that. Okay, but we still want to find our max min. We kind of know that's going to be our min because it's a bounce. Okay, but we're going to find it using calculus, and we're also going to find an inflection point. So let's start with the derivative to find max and min. So f prime of x is equal to 3x squared plus 6x minus 9. That is factorable, I think. X squared plus 2x minus 3. So that factors into x plus 3, x minus 1. Okay, so we know that the derivative is equal to 0 at x equals negative 3 and x equals positive 1. Let's find our y-coordinate while we're here. Plug negative 3 into here. I get negative 27 plus 27. That cancels. Positive 27 plus 5 is positive 32. Okay, so it looks like it's way up here. When y equals 1, I'm going to plug it in. Well, we know what y equals 1 is. We plug it in. It's going to be y equals 0. Sorry, x equals 1, y equals 0, because we know the minimum bounces here. Okay, so there it is. We have now our max point. Okay, I'm going to negative 3. It's going to be way up here. Okay, at 32. We also know that that point doubles as a minimum point. Okay, so the last thing is a part now we're adding on that we didn't do before is an inflection point. And I'm going to check for inflection points by finding the second derivative. So my second derivative is 6x plus 6. Okay, we want to find out where it's equal to 0. It's equal to 0 at x equals negative 1. So that means at negative 1, okay, there's going to be a point of inflection. Okay, in this case, I'm going to find the y-coordinate because, again, it's fairly easy to plug in. Negative 1 plus 3 is positive 2, plus 9 is positive 11, positive 16. Okay, so at -1, positive 60, maybe it's going to be somewhere around here. That's going to be my point of inflection. Okay, when I do my chart, I'm just going to shrink this a little bit so you can see my chart. My slope chart, I need to mark -3 and +1. You know, those are my zero slopes. And I can test my slopes. F prime at, let's say, -4. And I know that's, if I plug it into that equation, I get positive 48 minus, whatever it's going to be. I know it's going to be positive slope going through there. Okay, so when I plug in the negative value in here, I'm going to get my F prime being positive, so I know it's going up. It's going to have a max here. I kind of know it's going down here, but just make sure we're going to plug in a value. F prime at 0 is equal to -9, so that's negative. We know it's going down. We have zero slope or minimum point. And lastly, we'll test x equals 1, and we know that's going to be positive. Okay, we know that's going to go up in this direction. For our concavity chart, we're going to use -1. Okay, and then just test on both sides of -1. So I'm going to go F double prime of 0. That's an easy coordinate to test. I know I have positive concavity. Okay, and again, our slope graph indicates our positive concavity there. F double prime, let's choose -2. And if I plug -2 into this, the second derivative equation, yeah, I'm going to get -6. Okay, I know it's negative, which means it's concave down. Okay, so then I know that, and again, notice that the slope chart really confirms what I already knew, or the concavity chart confirms what I already know. So I'm going to sketch in the graph now. I know it goes positive slope through there, max. At that point, it changes from concave down to concave up, and it goes like that. Okay, so there is my polynomial graph.